Welcome to the Chapter 3 review for our Algebra 1 class. Make sure you show your work on every problem. Let's get started. Number 1. What inequality represents the verbal expression 4 less than a number x is less than 17? I'm going to chunk the phrase into different groups. So the first chunk is 4 less than a number x. 4 less than a number means that we're taking the number x and we're subtracting 4 from it. Is less than is the less than symbol, and 17 just comes down. So our answer is x minus 4 is less than 17. Remember, the 4 comes after the x. The most common mistake for number 1 would be 4 minus x is less than 17. That is not correct because it is taking away 4 from the x, not the other way around. Number 2, which number is a solution of the inequality? 15 is less than or equal to 5x minus 1. What we want to do is either plug in the options or solve for x and then see which option works. The way that I prefer is to solve for x, so that's what I'm going to do, and then see which answer option works best. So we're going to add 1 to both sides. That gives us 16 is less than or equal to 5x. We're going to do the opposite operation of multiplication, which means we're dividing 5 from both sides. So we have x, and we have 16 over 5. I've showed you before that we want to have the x on the left. It's easier to understand that way. And the only number that is greater than or equal to 16 over 5 is 16 over 5 itself. All the other options are less than, not greater than. So answer A is the solution. And make sure you showed work. Do not just choose answer A and leave it alone. By the way, feel free to pause this video at any point so you can catch up. Number 3, what inequality represents the graph? Well, first of all, it is an open circle. You want to write that down. And it is also shaded to the left. So that means we want to have our variable x. Our less than symbol, remember that symbol points towards the left, and there's no line underneath because it's an open circle, and our endpoint is between -8 and -6. That number is -7. For number 4, we have the inequality -3w is less than -15. We need to figure out the solutions, we need to graph the solutions, and we need to know how to describe the steps in words. So first of all, let's identify the operation between the -3 and the w is multiplication, so we should divide by -3 on both sides. The number on the right that we get, -15 divided by -3, is +5. Now remember, what do we do with the inequality symbol when we divide or multiply by a negative number? The answer is flip the symbol. So hopefully you were thinking that. So we have w is greater than 5. That's going to give us an open circle and shaded right. So let's go down to our number line. 4, 5, 6, open circle on the 5 and shaded in the right. Now, there are only a couple steps that we did here. The first step was divide both sides by -3. Why did we do that? We did that because we wanted to isolate the variable w. So let's write that. Okay, when we divide both sides by -3, we flipped the symbol because we were dividing by a negative, so we want to write that. And the last thing that we did was simplify and put it in inequality form. Alright, that completes number 4. Number 5 is very similar. What are the solutions of the inequality? X divided by 2 is greater than or equal to -6. Well, the operation that is shown is division, so we must do the opposite operation, which is multiplication. Multiply both sides by 2. So we have x is greater than or equal to -12. We're going to have an open circle and shaded right, because on the right is the numbers that are greater than -12. Closed. I'm sorry, I said open. I mean closed. Closed circle on the -12. Hopefully you guys caught that. Closed circle and shaded to the right. Okay, and that is it for number 5. So let's move on to number 6. We want to distribute the -4 in front, which means we're multiplying and sharing. Do not forget to multiply the -4 by the 4. People forget about that second number, so please don't forget. We have -4 times -2x, that is positive 8x. And then we're sharing the -4 with the positive 4, that is -16. Bring the right side down. Now we want to combine like terms. Let's get rid of the 8x's, minus 8x from both sides. Oh, the variables are gone. So that means we have a special case. The two options for special cases are all real numbers or no solution. So think about it for a second. Is -16 greater than or equal to -18? Because we were working with negatives, the answer is correct. So this is true because -16 is less negative than -18. When we have a true inequality, our answers are all real numbers. Okay, let's move along. Number 7. What are the solutions? We have -5x minus 9 minus 2x is greater than or equal to -7x plus 3. Combine like terms on the left side, so we get -7x minus 9 is greater than or equal to -7x plus 3. We want to combine the like terms on either side, so we're going to add 7x to both sides. The variables cancel out once again. That means we have a special case. Bring down the -9 and bring down the positive 3. Is -9 bigger than 3? No, it's not. So we're going to write false. And the answer is no solution. Remember, no solution means no number works for the inequality. Okay, in number 8, we have 6 plus 4c is greater than or equal to 3 times the quantity c plus 6. You probably thought this. We need to distribute the 3. Let's do that. 6 plus 4c is greater than or equal to 3c plus 18. Combine like terms. Let's bring the little one over instead of the bigger one. So we get a positive number in front. We have 6 plus 1c is greater than or equal to 18. Now we have a two-step inequality. Subtract the 6 from both sides. C is greater than or equal to 12. That is the answer for number 8. So that means all numbers that are 12 or bigger are solutions. In number 9, we have the inequality. X minus 5 is greater than or equal to 6. So first of all, we want to solve this, and then after we solve it, we want to put our answer in set builder notation. So it's a nice little one step, so all we have to do is add 5 to the other side, and we get 12, similar answer to the previous one. X is greater than or equal to 12. Well, if you can remember when we talked about set builder notation, I told you what you need to do is build around the answer. So you're going to take the answer and put some brackets around it or braces. bring down the x, and bring down a vertical line. So what that says is x such that x is greater than or equal to 12. That is the answer in set builder notation. So again, build around the inequality. Number 10 says, what are the subsets of -3, 7? So we have the set -3, 7. Well, a subset that is always a subset is the empty set. You can write that like that with empty braces, or you can write it like this. Either way, just know that it's called the empty set, and it's the set with no values inside. Now we want to list the set elements separately, and then list the set once again, because that is also a subset of the original set. And those are the answers. In number 11, what compound inequality represents the phrase and graph the solutions? All real numbers A that are less than 3 or greater than 8. So we're using the variable A, and let's just kind of split it up. Less than 3 or greater than 8. So hopefully it's obvious to you this is an or problem. A is less than 3 or A is greater than 8. And hopefully you recall that or inequalities are going in opposite directions. They will never cross paths. So let's label our graph 3, 4, 5, 6, 7, 8, 9. Open circles because there's no line underneath. And shaded it in opposite directions. Okay. In number 12, very similar, we need to graph our solutions, but this time we're given the inequality and we need to just get the x by itself. So this is an and inequality because the x is stuck in the middle, so that means our graph is going to be like an overlap. So first thing we want to do is add 4 to all sides. Add 4. So that means we have -6 is less than or equal to 2x is less than 12. And now we want to divide 2 from all sides. So now we're going to get -3 is less than or equal to x, which is less than 6. And that's our answer. And if you can recall, this is how you check. You basically take a number that's in the middle of those endpoints and plug it in to the original inequality and make sure it works. So we could easily choose 0. 0 is between -3 and 6. So let's take the 0, plug it in. I'll just show you on the side. Check. -10 is less than or equal to 2 times 0 minus 4 is less than 8. So 2 times 0 is 0, -4 is between -10 and +8, so it does work. Now we want to graph this, so we're going to have a closed circle on the -3 and an open circle on the +6. And we're going to shade between. I counted up by 2, so you can do the same if you like. Alright, number 12 is done. Okay, an application problem. A student scored 83 and 94 on her first 2 quizzes. Write and solve a compound inequality to find the possible values for a third quiz score that would give her an average between 85 and 90 inclusive. So first of all, let's define our variable. Let's use our x and say that that is the possible score for the third test. Alright, we're going to use the same format that we did for a problem like this and the bell work we did together. So our lowest score should be an 85, and our highest should be a 90, and we're going to be working in the middle. So our first two scores are right here. We have 83 plus 94 plus x. X is going to be the third test score, and remember, we're finding the average. That means we're adding the numbers up and dividing by the number of numbers, which is 3, the number of tests. So we have a nice and inequality going on, and we want to get the variable by itself, like normal. So first thing that we want to do is probably add the 83 and the 94. When you add those, you get 177, and then everything else is the same. So now we want to multiply all sides by 3 to get rid of the 3 in the bottom. So now we have 255 is less than or equal to 177 plus x is less than or equal to 270. Now we have a nice little one step, subtract 177 from all sides. We're almost done with this. And we get 78 is less than or equal to x, which is less than or equal to 93. So let's write a conclusion sentence. She must score between a 78 and 93 inclusive. Remember, inclusive means we are including the endpoints, and you know that it's inclusive because there's a line underneath the symbols. Number 13 is done. Number 14. How do you write x is greater than or equal to -9 and x is less than -6 in interval notation? So I'm just going to take some notes underneath what we're given. This is the important stuff right here. So greater than or equal to, that means we are going to include the endpoint. The line is underneath the symbol, and we're going to use a bracket. And for the less than symbol, we are not going to include endpoint, and that means we're using parentheses. So we take the -9, we take the -6, we put a bracket, and we put a parenthesis and call it done. That's a nice quick one. And this is an and inequality. If you were to write it, the shaded part would be in the middle of the two endpoints, but we don't need a graph for this one. Number 14 is done. Let's move on to number 15. We are given this problem. We have it in interval notation, and we need to bring it back into inequality form. So this is the exact opposite of a problem above. So take note that they are all parentheses. That means that we are not going to have lines underneath our symbols. The endpoints will not be included. Now, let's focus on the first part, -infinity to -7. So it starts at -7, and it goes towards -infinity. -infinity is to the left, so we're using a less than symbol and put the x down. Bring the or word, and now bring down the -4, and it's going toward positive infinity, so that means we have a greater than symbol. It's pointing towards the right, and we bring down the x. So the answer is x is less than -7, or x is greater than -4. Okay, number 16. We are given this in interval notation. We just need to graph it. So parenthesis means not included. So we're going to have an open circle. And then for the bracket right here, we're going to have a closed circle, so included. If it helps, I can give you the inequality. You don't have to know or write this down, but this may help you. Okay, so let's see. Open circle on the -3 and closed on the +2. Okay, and we shade in the middle. Remember, we shade in the middle when we don't see infinity. But when we do see infinity, then we know that they're going in opposite directions, and that would be an or. So this is an and inequality. Number 17, we are given another set interval notation, and we need to graph this. Oh, this is just what I was talking about. We have infinity, so that means it's going to be an or problem, as you can see. And I'll put it in the inequality form if that helps any of you. They're all parentheses again, so that means there's no line underneath. X is greater than 1. So now let's label our graph. We have -3. Open circle on the -2, shaded towards the left. And open circle on the +1, shaded towards the right. Number 18, absolute value. We want to figure out the solutions by getting the variable by itself, like usual. So first thing, get rid of that -2 by adding 2 to both sides. So you have 8, absolute value n is equal to 16. Now we have a one step, so we need to divide by 8. Remember, if you do not see an operation in between the number and the absolute value symbols, you assume that it's multiplication, so that's why we're dividing. So we have absolute value of n equals 2. What this is saying is n is 2 units away from 0, so that means that we figure out the two numbers that are 2 units away from 0. If you really need to have a number line, that is fine. I'm hoping that you can just figure it out. 2 units that way and 2 units that way. That would be -2 and +2. So the answers are n equals 2 or n equals -2. Okay, here comes an absolute value inequality. So take a look at this symbol right here. It is an or symbol. Remember, if it is like this, it's an and if it's like this, it's an or. My little trick was C for conjunction and D for disjunction or. So we know that the graph is going to be going in opposite directions. So very first step when you have an absolute value inequality, you want to get rid of the symbols. So pay attention closely here. D plus 4 is greater than or equal to 9, or D plus 4 is less than or equal to -9. One step, -4 from all sides. So D is greater than or equal to 5, or -4, -4. D is less than or equal to -13. So now let's graph that. I went up by 4s. You can choose this to the same or something different. And they are both closed circles because of the line underneath the symbol. So -13 and +5. And we're going in opposite directions. Okay, 19's done. Here comes an application problem. The optimal operating temperature of a given car engine is within 20 degrees Fahrenheit of 230 degrees Fahrenheit. Write an absolute value inequality for the range of acceptable temperatures and solve the inequality. So, word problems. First step is to define the variable. X is going to be the possible temperatures. So, the desired temperature is 230. So, the desired amount is always right after the variable. And we're going to have absolute value symbols around it. And it is within 20 degrees. So that means we don't want to go over 20 degrees. That's why we're having a less than or equal to symbol. Okay, first step is to get rid of the absolute value symbols. X minus 230 is less than or equal to 20, and x minus 230 is greater than or equal to negative 20. Add 230 to all sides. This is 250 right here. And 210. Now an and problem is having the x in the middle, and the smaller number goes on the left and the bigger number goes on the right. So this means that the acceptable temperatures for a car engine in this specific situation are between 210 and 250 inclusive. So here is another application of absolute value inequalities besides paper clips. Okay, sorry about that. Now let's move on to number 21. You have two boxes of colored pens. The first box contains a red pen, a blue pen, and a green pen. The second box contains a yellow pen, a red pen, and a black pen. What is the set that represents all the pens? So what you want to do is use braces and just list all colors of the pens that are listed. So this should be one of the easier problems for you. You just list the colors. Alright, number 22. A doctor is examining 3 patients. Which symptoms do all 3 patients have in common? For this one, you just want to figure out what is in the intersection of all 3 sets. It's in the very center. So write that on the side, intersection. Which is in the center. The 3 patients have a fever, tiredness, and joint pain. So the way that we can write that is in brackets, fever, tiredness, and joint pain. Remember, the braces or the brackets are just a way to show that it is a set. Okay, let's keep rolling. We're on the last page now. Let x equal the whole numbers that are less than 14 and z be the real numbers greater than or equal to 6.5. So the first thing that I did was write down the numbers that are whole and less than 14. So let's do that now. If you can recall, intersection of sets just means what numbers or values the 2 sets have in common or cross paths. So I have a list of the elements in set x and z. And the numbers that they have in common are 7, 8, 9, 10, 11, 12, 13. So those are the values that are in the intersection of x and z. Number 24. We have an absolute value inequality, and it is it's a less than symbol. So that means we have a conjunction, and this is going to be an and problem. And the graph will be an overlap. So, first of all, we're going to get rid of those symbols like we have practiced. X minus 9 is less than or equal to 3, and x minus 9 is greater than or equal to negative 3. Plus 9 and plus 9. X is greater than or equal to 6 with an and in the middle, And then, oh, we need to write our answer with union or intersection. Well, conjunction, the graphs are intersecting. So that means we want to use the intersection symbol. So the intersection symbol is, as I showed, the upside down U. And then the rest of it, all you have to do is just do set builder notation. So you build around it with the braces, make it all fancy looking, and that's how you do this problem. So again, and is the intersection. So you must use the upside down U symbol. You must know the difference between these two. So now let's do 25, very similar to the previous one, except this time we have a disjunction, which means we have an OR problem, and we're going to, our graph would look something like this, so we're going to have to take the union, and the union is nicely, conveniently a U. So we're going to use that symbol in our answer. First step is to get rid of those absolute value symbols. So we have minus 3, negative x is greater than or equal to negative 2. Interesting. The other side is going to be negative x plus 3 is less than or equal to negative 1. Subtract 3 from both sides. Negative x is less than or equal to negative 4. Now, which numbers are technically in front of the x's? Well, there's a 1 there. There's a negative 1. So we need to divide by negative 1. Beware, guys. We're dividing by negative, so the symbols must switch. So we're taking the x, symbol goes the other way, positive 2, and symbol goes the other way, positive 4. Now we want to use the union symbol and do our set builder, and we'll be done after that. You can pause at this time if you need to catch up. Okay, we're so close. We just have 3 more problems left. How do you write the set in roster form? In set builder notation. Okay, so a little bit of both. B is the set of whole numbers less than 4. Roster form is a list, just like a roster for a sports team. So whole numbers less than 4 are 0, 1, 2, and 3. And set builder notation. Set builder is the one where you describe your answers. So we have x is a whole number such that x is less than 4. So there's 2 ways to describe the exact same set. Number 27. Suppose U is the set pear, peach, apple, cherry, orange, mango. It's the universal set, and T is the set of peach and cherry. The question is, what is the complement of set T? Complement means whatever is in a certain set but not the other set. So I'm going to write that right here. Feel free to write it as well. Whatever is in set U but not set T. So one quick way to do this is to recognize, oh, set T as peach and cherry, cross out the peach and cherry in the original set, and the rest is the answer. Pear, apple, orange, mango. And that is the complement of set T. Okay, here comes the last problem. What are the solutions of the absolute value 3x minus 6 minus 5 equals negative 7? Well, let's get the absolute value by itself and then maybe get rid of it. First thing is add the 5 because it's outside of the symbols. Absolute value of 3x minus 6 is equal to negative 2. Okay, let's think about this. Absolute value means we are going to get a positive or keep a positive. There is a negative on the other side. That means that this won't work because you need to get a positive number. So that means there is no solution to this problem. absolute value cannot equal a negative number. Alright, this completes our Chapter 3 review. Thank you so much for sticking with me. Feel free to look at this on YouTube if you missed anything. And please, please, please study for this test. That means covering up your answers and trying it on your own and then checking your answers with your review. You will be turning this review in right before the test, so make sure you have your work shown on every problem and have your name on it, and you'll be good to go. See you soon.